Hello everyone, so today we will be going over some obscure cost optimization strategies that you can utilize on AWS. Most cost optimization advice out there is usually surface level, so things like right size your EC2s or delete unused DBS volumes. And don't get me wrong, those matter, but today I'm going to show you 10 powerful yet underutilized techniques that real cloud engineers most likely use to shave hundreds, if not thousands, of AWS bills. These are practical, real-world tactics that usually go under the radar. So let's dive in. Okay. So for starters, we've got one zone IA for recreatable data. So S3 standard is the go-to, but it's not always the best. Here and as a result, you have S3 one zone IA, this cheap but risky cousin of standard IA. It stores your data in a single availability zone instead of three. That means you lose the AZ level redundancy, but you gain a cost reduction of roughly 20 to 30% over standard IA. So when does this make sense? So think processed logs, temporary media files, exports, caches, data that you can afford to lose or regenerate. For example, if you're archiving daily exports from a database and you also want to keep the latest backup elsewhere, OneZone IA would be a perfect in slot for that strategy right there. To implement this is very simple. So you can simply use a S3 lifecycle policy to transition objects older than 30 days to OneZone IA and so on. And just like that, you have automated invisible savings. Um, Moving on, we have using VPC endpoints to eliminate NAT gateway costs. So NAT gateway costs. Here's the thing. One of the most silent budget killers on AWS is NAT gateways. Um, they charge you for every single gigabyte of data that goes out to the internet from a private subnet. At scale, that's hundreds or even thousands a month. Um, the solution to this, very simple. Use VPC endpoints, specifically gateway endpoints for S3 and DynamoDB, or interface endpoints for services like Secrets Manager, SSM, etc. These endpoints route traffic directly to AWS over the internal network, not the public internet. So not only is this more secure, but it's significantly cheaper. Gateway endpoints for S3 and DynamoDB are actually free, so there's no data transfer or hourly fees or so on. So let's let's work over a little example. So imagine you're running a data processing app on EC2 that uploads reports to S3. If that instance is in a private subnet um, and uploads 1 terabyte a month through a NAT gateway, you're paying $45 a month just for traffic. With a gateway endpoint, that will be zero. So if you're a small to mid-sized firm, this would be especially helpful when you're trying to cut costs as much as possible. So that is something to keep in mind. Moving on, we have sorry, 1 second. There we go. We have skipping EBS snapshots when no data is changed. So EBS snapshots are incremental, meaning you only pay for the changes since the last snapshot. Here's the catch: metadata and operations still cost money, even when there's little to no change. And if you're taking daily snapshots of volumes that barely change, you're paying for almost nothing. The solution to this is very simple. Use a Lambda function or a backup script that checks for volume activity before triggering a snapshot. You can use things like CloudWatch, get metric statistics to look at volume write operations and determine if any significant writes have occurred. Or you can use something like AWS Backup with a tagging strategy that skips cold volumes. Either way, um, automating smarter snapshotting is the wise thing to do. Essentially, what we're trying to do is don't pay AWS to save nothing. So this is another silent budget killer as well. So you want to be very careful. Next up, this is one of my favorite ones, is use Graviton instances for 40% or more savings. So AWS Graviton is based on the ARM architecture, and it's a beast when it comes to price to performance. You roughly get 40% more throughput per dollar compared to Intel or AMD based EC2 instances. So why isn't everyone using them? Well, people assume ARM isn't compatible, but here's the truth: most modern software tech stacks, for example Node.js, Python, Java, Go, etc., it runs just fine on ARM. Not only that, but Docker supports multi-arch builds too. So it's a common misconception. So try using something like a T4G.small instead of a T3.small for small workloads, or a C6G instead of a C5. For Fargate, set the platform to ARM64 in your task definition. The cost savings for this stack up pretty quickly, especially for microservices and containerized apps. So if that is something that's included in your architecture, that is something that you most certainly want to. This might be something that might be worthwhile looking into. So next up we have Spot Fleet with capacity optimized pools. So Spot instances can cut EC2 instance or EC2 costs, sorry, by up to 90%. But many people run them in isolation and get frustrated when they're interrupted. Instead, use Spot Fleets or EC2 autoscaling groups with multiple instance types and availability zones. Set the allocation strategy to capacity optimized, which tells AWS to use less volatile pools, even if they're a few cents more. Uh, let's use a real world use case for an example here. So let's say you're running a CI/CD pipeline, you're rendering jobs, or you're doing ML training. Anything that's fault tolerant, a diversified Spot Fleet gives you the savings without the instability. So it's very powerful, and definitely worth checking out if you're using if you're using it for those any particular purposes and you're looking for fault tolerance. Next up, we have using a compute optimizer for Lambda sizing. So Lambda pricing is based on memory and duration. So if you're watching this video and you're about to take the exam, I believe the longest time a Lambda function can run for before it automatically times out is about 15 minutes. So that is something that could come up in your exams. So do keep that in mind. So if you're using 1 gigabyte of memory for a function that only needs 128 megabytes, you're massively overpaying. AWS Compute Optimizer now supports Lambda and gives recommendations based on real usage patterns. It might tell you to drop memory from 1024 megabytes to something like half of that, so like 512 megabytes, or even bump it up higher, uh, or even bump it up if higher memory reduces execution time. So essentially, the formula you want to keep in mind is less time times less money equals exponential savings. You can save anywhere between 30 to 50% just by fine tuning memory allocation alone. That's all. Next up, one of my favorites as well is automatically stopping non-production RDS when it's off peak or at night, for example. So you want to ask yourself, sorry, 1 second. You want to ask yourself, why are your staging or QA databases running 24/7 when nobody's using them at 2 a.m.? You can use something like AWS Lambda or plus Event Bridge to stop RDS instances during off hours and start them again in the morning. A simple schedule would look like, say, stop at 7 p.m. and start at 7 a.m. So it saves you 50% or more on RDS costs. Add a manual override in your admin dashboard if you really want to, if needed. But yeah, this is one of the things I encourage if you have an architecture that you don't want running, or if you don't have to have it running constantly when it's not work hours and so on. So yes, a very very powerful way, a very easy way to save money this way. Next up, we have consolidating billing with AWS organizations. So when you're running multiple AWS accounts, you can consolidate them under AWS organizations. It's free and you get volume-based tiered pricing applied across all accounts. So let's work with an example here. So let's say normally S3 costs 0.023 gigabytes for the first 50 terabytes a month. But if your organization uses 100 terabytes across dev, production, and backup accounts, you can reduce that 23 down to a 21 rate across all of them. So if you're working with an architecture or a system that's going to scale very quickly, then that is something that can definitely save a lot of money over time, especially at scale. So, and not only this, it also gives you centralized billing, it gives you budget alarms, and access control through service control policies or SCPs. And once again, if you are revising for your exams, then when you're working with AWS organizations, you're very likely to come across SCPs when it comes to managing control between resources. You want to definitely keep that in mind. AWS config is also something that's most likely to come up when you're trying to manage compliance within the organization. So these are very popular questions in the exam, so do keep them in mind. But yeah, moving forward, we have the second to last one. We've got not putting Lambda in VPC unless it is required. So if your Lambda doesn't need access to resources inside a VPC like an RDS or an Elasticache would, then don't put it in a VPC. Why? Because once you do, cold start times tend to skyrocket, and you need a NAT gateway for internet access, which costs you. So instead, Lambda outside of a VPC can talk to public services like S3, DynamoDB, or SNS directly. It's faster, it's cheaper, and it's more efficient. So once again, if you don't have to put it in a VPC, then by not doing that, you will be saving some costs. So that is something to keep in mind. Let's go to the final one, and that is using compute savings plans like reserve or over reserved instances. Yes, so reserved instances lock you into specific instance types and regions. It's not ideal if your architecture is evolving or you're scaling up and is most likely prone to changing fundamentally. So it's something you want to keep in mind. It's not it strips you of that flexibility. So instead, you can use something like compute savings plans, which is great because they apply to any EC2 instances in any region and of any size. And even Fargate and Lambda are also susceptible. They can also be used by that. And this gives you extra flexibility. It gives you savings up to 66%, and so on. And this is ideal for teams that are scaling microservices or shifting to containers or serverless over time. So yes, something to keep in mind when you're working with that. And with that, we'll be wrapping up. So that is some 10 obscure cost-saving strategies that most people either overlook or don't know about. And we've had a few exam tips there as well if you're again preparing for the solutions architect or even the foundational for cloud practitioner. Um, we had things like smarter lambda sizing to eliminating NAT gateway waste. Each one of these can make a measurable dent in your AWS bill, so please do keep them in mind. If you found this valuable, please don't forget to hit that like button, subscribe button, and hopefully you guys will tune in for the next video. So yeah.